This single color, born from a lab accident, shaped art, science, and war. In the early 18th century, painters relied on expensive, often unstable pigments. Ultramarine, derived from ground lapis lazuli, was a king's ransom. Cochineal offered reds, but blues were a perpetual problem, a constant drain on resources and artistic ambition. That is, until a seemingly innocuous experiment in Berlin went spectacularly and serendipitously awry. The year was 1704. A dye maker named Johann Jacob Diesbach was attempting to create a new red pigment. He was working with cochineal and iron sulfate, but crucially, he needed some potash. He borrowed some from a colleague, Johann Conrad de Pell, an alchemist known for his eccentric experiments and foul-smelling animal oils. De Pell's potash, however, was contaminated. It had been used to distill de Pell's infamous animal oil, a concoction that left behind a residue of blood, bone, and other organic matter, rich in nitrogen and carbon. When Diesbach added this tainted potash to his mixture, something unexpected happened. Instead of red, a deep, intense blue emerged. This wasn't just any blue. It was a hue unlike anything seen before, vibrant, rich, and remarkably stable. The accidental combination of iron salts, potassium ferrocyanide, formed from the organic waste in de Pell's potash, and a touch of chemical magic had created what we now know as Prussian blue. A new chapter in color history had begun. The discovery was initially kept secret, a valuable trade secret for Diesbach and de Pell. But secrets, especially profitable ones, rarely last. By 1710, the recipe had leaked, and Prussian blue began its journey across Europe, revolutionizing the art world. Painters no longer needed to rely on the exorbitant cost of ultramarine. Artists like Antoine Watteau, Jean-Honoré Fragonard, and even later, Katsushika Hokusai embraced its vivid intensity. Think of Hokusai's iconic The Great Wave off Kanagawa. That distinctive deep blue is Prussian blue. It democratized the color blue, making it accessible to a broader range of artists and patrons. But Prussian blue's impact wasn't confined to the canvas. Its unique chemical structure, a complex coordination polymer of iron and cyanide, fascinated early chemists. It became a subject of intense study, pushing the boundaries of chemical understanding at a time when the field was still in its infancy. The very nature of its accidental creation spurred further investigation into inorganic chemistry. It was a puzzle, a beautiful enigma that hinted at deeper principles governing chemical reactions, long before the periodic table or modern atomic theory were fully conceived. Fast forward to the 19th century, and Prussian blue found a new, unexpected application: blueprinting. The pigment's sensitivity to light, specifically its ability to decompose under UV radiation when mixed with certain iron compounds, allowed engineers and architects to create durable, inexpensive copies of their designs. This innovation revolutionized construction and manufacturing. Designs could be shared quickly and accurately, accelerating industrial progress across the globe. From towering bridges to intricate machinery, Prussian blue was the silent enabler of the industrial age's visual communication. Yet the story takes a darker turn. The same chemical properties that made Prussian blue so useful also made it a precursor to something far more sinister: chemical warfare. The cyanide component, while bound within a stable lattice in the pigment, pointed towards the deadly potential of cyanide compounds. While Prussian blue itself isn't directly toxic in its pigment form, its chemical relatives, like hydrogen cyanide, became instruments of death. The research into its composition inadvertently contributed to the understanding of cyanide chemistry, which would have devastating consequences in the 20th century. During World War I, the first large-scale chemical attacks unleashed chlorine and mustard gas. But the shadow of cyanide, understood in part through compounds like Prussian blue, loomed. Though not directly used as a battlefield weapon until later, the intellectual pathway had been forged. The tragic culmination came during World War II with Zyklon B, a pesticide that released hydrogen cyanide gas. This horrifying weapon, used in the Holocaust, stands as a stark reminder of how scientific discoveries, even accidental ones, can be twisted for unimaginable evil. It's a grim irony that a pigment born from a quest for red, then morphing into a brilliant blue that adorned masterpieces, would have such a tangential yet profound connection to one of humanity's darkest chapters. The accidental discovery of Prussian blue highlights the unpredictable trajectory of scientific knowledge. But the story doesn't end in darkness. Prussian blue has found a surprising role in modern medicine. Its ability to bind with certain heavy metals makes it an effective antidote for thallium and cesium poisoning, often used in cases of accidental or intentional radionuclide contamination. In a remarkable twist, the same chemical principles that gave us a beautiful pigment and tragically informed the development of chemical weapons now offer a lifeline against radiation exposure. It's a testament to the dual nature of scientific progress, capable of both destruction and salvation. From a forgotten corner of an 18th-century Berlin workshop, a simple error in mixing ingredients created a color that would adorn the canvases of masters, underpin the Industrial Revolution, cast a long shadow over the ethics of chemical warfare, and ultimately save lives. The pigment known as Prussian blue, initially dismissed as a mere accident, embodies the complex, often contradictory legacy of human ingenuity. It's a reminder that the smallest, most unforeseen events can ripple through centuries, shaping art, science, industry, and the very fabric of human history. What other overlooked historical accidents do you think deserve a deeper look?